Yeah, I'm doing it.
So I'm going to solve both of these. Listen. I'm going to solve both of these and talk about why A is our answer. So we would subtract 5 to this one. Negative 9x is less than or equal to 12. Divide both sides by negative 9. Because we're dividing by negative, the sign is going to change direction. And then reduce your fraction, so negative 4 over 3. Do the same thing to the other one. Subtract 25 on both sides. Divide both sides by 13. And then if we had to graph this on a number line, this is equivalent to negative 1.3 repeating. So on our number line, if I had negative 2 and negative 1, negative 4/3 would be somewhere right here. So we have x is less than or equal to negative 2, closed circle going to the left. And then x is greater than or equal to negative 4/3. Again, a closed circle, but going to the right. If we're looking at everything, reading it left to right, we have everything less than negative 2, or everything greater than or equal to negative 4/3. So A is the only one that works for that one. Do we have any questions about that? So remember that Khan Academy is for or. They're looking at all. So where do both of these fit or work? But for us, it's just they're graphing apart no matter what. Let's do this and then we'll talk about that. No, there is. I was drawing or erasing, so I had to go back to it. All right, so everyone should have these notes in front of them. Pay attention. Graphing inequalities is very similar to graphing lines in general. There's just a little bit of differences. So similar, they both need to be in slope-intercept form before anything else. And then here is where it's a little different. When we graph our inequalities, we're going to be graphing it specifically based on the symbol. So if we have strictly less than or strictly greater than, we're going to use a dash or a dotted line. And then if we have less than or equal to, greater than or equal to, we're going to use a solid line. Some of you may remember this from 2 years ago when you learned this originally. I don't know if this is done in geometry or not. And then on top of that, so the line is different, then we're also shading our graph to see the solution area. So if we have less than or equal to, we shade below the line. And then for greater than or equal to, we shade above the line. So we're going to do some examples, starting with one. If you need a ruler, there are some in the colorful cart. So for number one, we're going to graph this like a normal line. Start at your y-intercept of -5. Your slope is 1/3. Go up 1, to the right 3, as many times as possible. And then down 1, left 3 as many times as possible. Fill up your graph. And then look at your symbol. This will tell you if this is going to be a dashed or a solid line. It doesn't have that inequality equal to, so this is going to be dashed or dotted. So you can do one of two things. Either draw a line like normal and then erase parts of it, or draw little dashed lines in between. Either or. Try to make them as straight as possible. Mine clearly was not, so. Then the second piece, we have to figure out which direction to shade. Greater than tells us we're going to shade above. Sometimes the graph is hard to tell which way is above, which way is below. So if you look at your y-intercept and you draw an up and down arrow, above would be up, below would be down. So if this is supposed to be above, we're going to shade everywhere above. How you do that is up to you. Whether you want to fill in all of the squares, fill in some of them, do what I just did, draw lines, highlight, whatever. As long as I can see that it's shaded. Questions on the graphing piece? So, look at the symbol. So, greater than is always above. Greater than or greater than or equal to is always above. The other two are below. Look at your y-intercept and draw up and down arrows. Up would be above, so if this is supposed to be above, follow the up arrow and shade that area. Right. Any other questions on the graphing part? Right. This next piece is to help you check yourself. We have different ordered pairs to determine if these are solutions or not. If they fall in the shaded area, it's a solution. If it doesn't, it's not. So would 0, 0 be a solution?
Yes.
Yes. 0, -5 falls on this line. We're going to talk about that here in a second. We'll come back. 3, -2, would that be a solution? Yes. 5, -6. No. And -7, 3. Yes. So for 0, -5, the general rule, if it falls on a dashed or dotted line, it is not a solution. But if you forget that rule and you want to double check yourself, just like you would double check yourself algebraically with a regular equation, you would do the same thing here. Take this ordered pair, put it into this inequality, and see if you get a true or false statement. So I have my inequality here. I'm going to take that ordered pair and put it in there. So -5 is greater than 1/3 x minus 5, 1/3 0 minus 5. This would just become 0, so -5 is greater than -5. Is this a true statement?
No.
No. If it said equal to, then yes, but because it doesn't say equal to, it's not a true statement. So that's not a solution. So that's a good way to check yourself every single time. Did I graph this right? Now I will say sometimes you'll graph it wrong and pick points in your own solution area that will make it right. So if you are checking it graphically, it could work, but check it algebraically. That would actually tell you if it worked or not. All right, questions on this? All right, let's try number 2. So again, start off like normal. Y-intercept of -1. Slope is -2, so up to left 1 as many times as possible. Down to right 1 as many times as possible. And then looking at the symbol, would this be a dashed or a solid line? solid, and solid lines are just like normal lines. We connect all the dots and draw arrows. Right, looking at your symbol again, would this be shaded below or above? Below, because it's less than. You don't have to write these, it's just to help you if need be. So again, if you're not sure which direction is which, look at your y-intercept, draw arrows up and down. Below would be down, so this area right here. Right, and then just as before, we can check to see, do these points fall in the shaded area or not? -3, 6. Would that fall in the shaded area? Is that a solution? No. 0, 0? No. 0, -1 falls on the line, but because it's solid, it should be a solution. But just to double check, we can put it back into the inequality. So this would be -1 is less than or equal to -2 times 0 minus 1. Or -1 is less than or equal to -1. Is this a true statement? Yes, because of the equal to. So that is a solution. -4, 0. Is that a solution? Yes. And 4, -3. Is that a solution? No. Okay. Questions on this? If it feels easy, good. If it doesn't, that's okay as well. Right. Once you've written that down, go on to the next page. We're going to do number 3. Right. If we don't have an inequality in slope-intercept form, we have to get it there first, just like you would with an equation, or, yeah, sure. Get rid of your 5x by moving it to the other side. You have -2y is greater than -5x plus 12. And then to get y by itself, we would do what? Divide everything by -2. The sign would also change, yes. So y is now less than a positive 5 over 2x minus 6. I know the green is a little hard. I was trying to write in a different color, sorry. Alright, so start at -6. Go up 5 to the right 2. As many times as possible. Would this line be dashed or solid? Dash. Be careful with finding points on your dashed line, especially if it's not straight. Would this be shaded above or below? Look at this side. Below. So less than is always below. Now for this one, if you're not sure, again, look at your y-intercept. Draw up and down arrows. Below would be underneath. Underneath is right here. Someone give me one ordered pair that would be a solution.
3, -1.
3, -1. That would work. Anyone else want to see if their solution point would work? Bless you. Okay, so we're going to do one more on this, and then any you guys want to see, and then move on. We're going to do number 8. So notice that this is an x inequality. So your $40 has come back. Horizontal lines have 0 slope and are y equals, or in this case, y inequalities. And then vertical lines have undefined slope and are x equals, or in this case, x inequalities. So since this is an x inequality, this is going to be a horizontal or vertical line? Vertical. At 6, so start at 6. 1, 2, 3, 4, 5, 6. Put a point there. Is this line going to be dashed or solid? Dashed, because it's strictly greater than. So when you draw your vertical line, just make sure it's dashed and has arrows. X inequalities are a little different because there is really no above or below. It's really left or right. So you have to think about number-wise, which of these sets of numbers would be greater than 6? If I start picking numbers over here, would like -5, 0, 3, would those numbers be greater than 6? No. So that means it has to be the other side. So if you're not sure, pick a number, ask yourself for x. Is this greater than or less than or whatever it says to the number given? Someone give me one ordered pair that would be a solution. 7, 1, that works. All of those, yeah. In reality, these go on forever and ever off the graph. So if I said like 7 billion, that would still work. We just want to write ordered pairs that we can see, because I can't see that one. All right, questions on that? Okay. Look on this page and the very last front and back page that has practice problems. Find any you want to see, go over, have questions about, not sure where to start, anything like that. So this page or the very last page that looks like this. Any of those we want to see, go over, have questions about. Any others? 6 on this page, on the last page. Okay. Any others? 11. Okay. So let's start with 6 on the same page. I'm sorry, 7 on the same page we were already on, and then we'll do the other 2, and then we'll move on. So with 7, this is a y inequality, as this can be horizontal or vertical. Horizontal at -4, so put a point there. Will this be dashed or solid? Solid, because it's equal to. So draw a line through that point just like normal. For y inequalities, it's really easy to see above or below. So this should be below. So it would be everything under. You can still do the arrow to see, but it's just up or down. Questions on that one? So because we're shading below, it has to be underneath. No, the rule is this direction is below, is underneath.
And how did you do that?
Because it's greater than, pick a number on the number line, that would be greater than 6. 7 is greater than 6. 3 is not. Great. To the very last page, we'll do 6, and then 11, and then move on. For number 6, y-intercept is -1, so start there. Slope is -2/5, so go up 2 to the left 5, down 2 to the right 5. Would this be dashed or solid? Solid, because it's equal to. Nicole, make sure you're writing this stuff down. And then shaded above or below? Above, because it's greater than. If you're not sure which one that is, draw your arrows up and down. Above would be up, so up here. It doesn't say this, but if I said, give me an ordered pair that would be a solution, tell me one.
0, 6.
0, 6 would work. Alright, questions on that one? And then flip over so we can do 11. What is our y-intercept here? 0. We just don't see it. So then our slope would be 3/5. Go up 3 to the right 5, down 3 to the left 5. Would this be dashed or solid? Dash. And then shaded above or below?
Below.
Below. So that would be underneath. Give me one ordered pair that would fall in the shaded area. No. Questions on that? Yes.
A solution can fall on the line, right?
For solid lines only. Right? So now let's go back to our writing piece. Where was that? This page, the one that looks like this. And now it's like opposite. So now we're given graphs, and now we have to find what the inequality is. Some of the steps are the same, but instead of graphing our slope and y-intercept, we have to make sure or figure out our slope and y-intercept, find it on the graph. The rules for the dashed and solid line, shaded below and above, are the same. I will say solid lines are easier to find all the information than dashed lines, but we'll still figure it out. Start with your y-intercept because that's going to be the easiest. Where does it fall on the y-axis? On the y-axis?
9.
Is that 80? So I know on the paper the numbers are printed very small, but it should be at 8. Let's do this in different. Okay, so we know this much so far about our inequality. It's going to be at a positive 8. For our slope, find 2 points that you see that crosses grid lines exactly. I would say look on your dashed lines for that. It could be any point you find, so let's say I saw this one, count your slope. What would that slope give us? Say it again. If we go down and then to the right? If you're close, you just have them switch.
-4 and 2.
Okay, which would reduce to -2.
-2x.
So our slope and then x, so we have -2, then x. Okay, so we're getting more of our inequality. Now we just need to know what symbol. So it's dashed, so it has to be either greater than or less than. We have to look at where it's shaded. Because of our y-intercept, it's shaded above it. So yes, that would be greater than. Now the solid is going to go a little faster because you can easily see all the points. Oh, also, I skipped some. For your slope, when you find your points, make sure that's your slope for all of them because you could think that, but not for everything. So if you think it's -2, just double check that that pattern follows everywhere. So if I go down 2 to the right one and I keep doing that, does that pattern follow? If it does, then that is for sure your slope. I skipped that earlier. If you start to do that and your line is like veering off from the points you're making, that's probably not your slope. So just be careful with that. Alright, for number 2, what's your y-intercept? Excuse me. Where does it cross your y-axis? Mm-hmm. Our slope is what? 1. I'm going up 1 to the right 1. And that pattern follows. And then I'll put my x behind it. It's solid, so I know it's going to be greater than or equal to or less than or equal to. Look at where it's shaded. Is this shaded above your y-intercept or below it? Below it. So less than or greater than? Less than. This doesn't get harder than this. Questions about that? Look on the back of this page, see if there are any questions you want to see, go over, have questions about. Any that we have questions on? If not, I'm going to show you something in your calculator so you can check yourself. So if you don't have that, go grab it. Yes. We can do that real fast, yeah. I know your shading is not as good as mine, / the color is not on yours. So just make sure that you can see that this should be your shaded area. So since this is a vertical line, it has to be some x. We know this goes through -2. It's a solid line, so it has to be less than or equal to or greater than or equal to. Look at the numbers it's shaded on. Are these numbers less than -2 or greater than -2? Less than. So x is less than or equal to -2 would be your final answer. Great. Go grab your calculator if you don't already have it. grab your calculator. Yeah, go ahead and write your fast. Eva, grab your calculator. Okay, my bad. Alright, so in your calculator, reset it first. Second plus 712 except 5. Second plus 712. So reset it first. Second plus 712. Then you're going to go into apps, right by math, apps. You're only going to have 4 or should only have 4. I have a bunch because it's the computer. If you don't have 4, raise your hand. Apps. This makes the math. And then you're looking for inequals. inequalz. Once you find that, make sure it's on that line. Hit enter.
The inequalities, right?
Yeah. And then hit enter one more time. If you're not on the screen, raise your hand. Inequals or apps, inequals, enter, enter. Anyone else not on that screen? So did you do this? Apps. Apps. Find the button that says apps. Inequals. Enter twice. Okay, so if you are hovering on the equals, you'll see these buttons pop up. It's small. I have to keep flipping back and forth so you can see them. These buttons pop up. In order to get to those, we have to hit alpha, whatever button is underneath. So let's say we wanted to do less than 2x plus 1. We need the one on top of window. So alpha, window. And it will change your inequality symbol, or should. And when you look over here, you should see that this changed from a line to shading, and it is now dotted. You can go to the right and then put in the rest of your inequality, 2x plus 1. Ethan, you can go. Okay.
How did you know that?
Practice is the only thing I can tell you. And I taught Algebra 1 since they worked here. So graph this. I hit graph. It will graph it for you. It will show you the direction it's supposed to be shaded, as well as is your line solid or dashed. So this is a good way to check yourself. Make sure you graph things correctly. Go back. We're going to try one more. So go back to y equals. Let's change this to greater than or equal to. Yes. Y equals. So greater than or equal to, let's pick a fraction. So greater than or equal to first, or I'm sorry, clear it out first. And then if I want a greater than or equal to alpha graph, Now you'll see that it's still shaded, but the direction has changed. It's now a solid line.
Yeah, how'd you change the thing?
Alpha, whatever button is underneath it. But I hit alpha graph, yes. In this mode, you cannot use fractions, unfortunately. So you have to put them in parentheses. So like 1 divided by 2x. Yes. You're going to be after Sajid. Yes. Okay. Yeah, just the division. After you have this, graph it. Sloan. Yes. When you're on your equals, these buttons should pop up. Just hit alpha graph. Once you have this, graph it. And then same thing, it should show you where it's shaded, if it's solid or not. Sure. Alright, so in your calculator, that's a good way to check yourself. I'm going to show you on Desmos for when you're at home practicing / when you're practicing Khan Academy. Not for the tests, because remember that's still your calculator. If I typed in a whole inequality in, it will graph it for me, show me where it's solid, dashed, above, below. If you're doing multiple problems, probably don't do them at the same time until we get to systems. Alright, questions on the calculator or Desmos? Use them while you're practicing, double check your work. Okay. So for the remainder of class, you have time to practice. Go back, look at the problems in your notes, practice those. You can knock out the Khan Academy, get them done. The one from compound inequalities, the 3 on graphing, but 2 of them are due this week, 1 is due next week. Or the one from last week on multi-step inequalities. Be working on some